it's something that it's frustrating to us because, one, we would like to give them back to you, but just people that are being dishonest and claiming stuff as their own is the main reason we don't hand anything back to you as far as those session quizzes. But please know you are always welcome to come in and look at it, go over it. Even if you went over it before, you can come in again and take a look at it. You're not bugging me. But I do grade fast. Mainly how I grade is I come in early in the morning. I usually get into the building by 5:45, and because there's no one here.
Wait, actually?
I do, yeah, seriously.
Why? Why would you not go? I wake up at 6:30.
Well, one, I have the med class, which is normally before school.
Oh,
It's not. That's by my choice. I made the class, so don't.
Oh, you made the class?
Yeah, it's a class that I designed.
I
Yes.
wish I could take it.
Well, next year you take it.
I can't take it.
Why?
Because next year I have like too much. Like, I just like don't have time. I know that it's before school, but like because I have a plan.
Because you have a plan.
I actually you'll see me before next.
I will just say that.
That's there's no homework. You just listen.
Yeah. Okay.
You'll see me next year.
Don't ever threaten me like that again.
So don't do it. Like,
I'm just joshing with you. Yeah, the class is for juniors and seniors. Would be honored to have each and every one of you in the class next year. If you're already in there, I guess you have to be my student aide. You can be the dead body.
Oh.
That was the best thing I've seen all day. No, we're making a paper airplane and it flew so straight. All right. Homework is out, I think. Yep. I haven't put a mark on it. Dang it. I'll be all right. Is this up? Who?
Yeah.
Firewall fails.
I failed algebra 1 and 8.
Come on. All right, taking a look at that very first page on the homework. Why can't we connect? Any questions on the first page? It looks like page 67. Number 7. It says to us, identify the domain and the range of the relationship using interval notation. Okay, so number 7. Give me a break. Hopefully that'll work. If it doesn't work, we'll have to do something else. Up there. So number 7, that function on number 7, you don't know it yet. Oh, good, it went. See, I just had to come over and act like I was threatening it. Let me get to the end of my things. Dude, we're gonna be like graphing like no other today. So I hope you came with your. Nothing. All right, so number 7 looks like this. I'm just gonna graph this. This is what it looks like. It doesn't have a gap in it like that. Correct?
Yep.
And they want the domain and the range. Agree? Okay, so does it appear that the graph will continue to go this way in the x direction, how that arrow's pointing?
Yes.
Okay? Does it appear the graph is going to continue that way even though it's going downward? Okay, so the domain will go from negative to positive infinity. Okay, now with the range, does this appear that it's going to go forever up? Okay, so where's it coming from? No, where's it coming from? You read it left to right. Read it left to right. So as I'm coming along with the left, where's that one coming from? Positive infinity. As I go this way, where's it going to in the y direction? Please don't mix them up. And it honestly, interval notation is very simple, but it's easy to goof up. Yeah. And then it says determine if the relation is a function. If I look at it, the vertical line test passes every time, right? Even though the lines, as they go out towards negative infinity and come in towards, go to positive infinity, they appear to be getting very close to vertical. They will never be a vertical line, so this is a function. 12. That one you just have dots on, right?
Yep.
Okay. So number 12, it looks like, oh shoot, I can't see this. Is that negative 3, 4 is one of the points. I'm just listing what the points are. And then I got negative 1, 0, 0, 1. I might not have this in perfect order. 1, 2. 2, 0. 3, 4. And please correct me if I have any of these wrong. 3, negative 1. Is that all right? All right, so I'm just going to list the domain. So the domain, come on, go to red. Okay, I underlined the red. If we put those in order from least to greatest, that's your domain. Your range we'll do in blue. If I put those in least to greatest order, that's my range. If the domain repeats at all, if any of the reds repeat at all, it won't be a function. Do any of the reds repeat?
Yep.
They do. I have this, and I have this, and there might even be more. Nope, that's it. So those two, because they repeat, mean it's not a function. Okay, the vertical line test doesn't pass. All right, let's flip the page to page 68, if that's okay. Page 68. So let's just look at 13 through 18 first. And the 13 through 18 says, hey, is it even, odd, or neither? And then determine if it's 1 to 1. Okay? Any questions on 13, 14, or 13 through 18? Yeah.
What about 14?
14.
Squiggly line.
Okay, it's got a wiggle. So it appears, I'm not going to draw it perfect. It's kind of like this, yes?
Yeah.
Okay. So I'm going to have it symmetric about this. So if I rotate the graph all the way around, will this here match up to here? Will this match to here? Will this match to here if I rotate it around 0, 0? It does?
No.
What?
Yes.
Yes, it does.
I thought you said no. I'm like, I told you I didn't draw it perfect, right?
Yeah.
So it's an odd function because I can rotate it like a propeller around the x-axis. It winds up in the same location from quadrant 1 to quadrant 3. So odd functions rotate around the origin. So it's a double rotation. So if you think about it, does this as I rotate around become here? Does, say, this point as I rotate come around to here? Does this point, say, when I rotate come around to here? If the answer is yes, it is an odd function. Is it 1 to 1? Well, 1 to 1 has to pass the horizontal line test. Does the horizontal line test touch it twice or more?
Yes.
It does. It is not 1 to 1. It is not 1 to 1. And it's that simple. So the horizontal line test is, do any of the values in the range repeat? If they don't, it's 1 to 1. Make sense? Yeah, question? Go ahead.
So even is if you flip it the other way around.
Even means, could I, an even function, let me just find one. It's like number 13's even, okay? Here's our thing, comes down like this. It's an absolute value function, okay? Drinking. All right, so if I take this and flip it over top like this, that means it's even. And again, horizontal line test doesn't pass, so this is not 1 to 1.
What?
Yeah.
What about 16?
16, you got it. So someone said what? What's your question on it? 2, is that 2, 3? All right. So we want to know if this is even. Well, I can't flip it over the y-axis, because if I flipped it over the y-axis, I get a completely different graph, even though it comes down. It's just the vertex moves over here. So it's not symmetric about it. Symmetric meaning I can fold it over the y-axis. So it's not even. And then I think about odd. If I rotate this here and then flip it here, does the graph still exist right where my finger is? No. So it's not odd. 1-to-1? Nope. It's going to cross it twice, so it's not 1-to-1.
Nothing.
Yeah, it's nothing special about this one. Yes?
So does that mean if there's any of them that are not on like the y-axis, or is it gonna be either? Because
Yeah,
that was like not on it. It's on.
Right. So the even functions on that particular thing, number 18's an even function because it folds right over. 16 is not, because we just did it and we just proved it. 15 is not because it doesn't reflect over. 15 is actually an odd function because if I rotate around the origin, it goes here. It goes like this. Ready? One rotation. And that rotation.
Oh, that makes sense. So like if it'll usually be neither if it's not.
If it's not even or odd, it still could be 1-to-1. It's just it doesn't have to be.
Oh, how do you tell even?
Okay, even. Okay, y-axis, vertical line. If you could take your graph and you could fold. I'm trying to answer you, and you start looking away. Okay, you ready? All right. Let me just draw this. If I could fold right over top, and it lies on top of itself on the other side of the y-axis. It doesn't matter if it opens down. I mean, you could have a parabola upside down. You could have it open up. That means if that happens, it's even. It's odd if I can rotate from a quadrant to a quadrant. So fold it over the y-axis, and then fold it over one more time, and it kisses itself on the x-axis. Okay? I have a great thing I can show you. Does somebody have a piece of paper that I can have? No. Any piece of paper. Perfect. Okay. Straightforward as I can get. Okay, dead pen. I was aiming for that, the floor. XY axis, still with me? I know this is as generic as it comes. Okay? So, drawn just a smiley face, one eyebrow. I did one eyebrow on purpose. Okay? Ready? So if I wanted to make this even, it's not a function because it's not going to pass a vertical line test. But if I wanted to make this even as simple as possible, I'm going to do this. I'm going to fold right over top. Like that. You with me? Now this is what I'm going to do. I'm going to use this light. Man, I wish they'd give me nice things that worked. Okay, ready? Now I'm going to put just a plus mark here on my page that I just made because it'll be the reflection. Okay, ready? So here's my original. That's even. It went right over top. You with me?
Yes.
Okay? So it went from here to here, even function. I'm sorry I'm not the best artist in the world. If I want it to make it odd, now I'm going to have it creased as I normally did, and I'm going to crease it one more time. Okay? Now, unfortunately, oh, I can see. Cool. Back when I first started teaching, we used to use something. We used to bring in hamburger patty paper, that wax paper that is in between hamburgers, because it actually works really well with this. Unfortunately, we get technology now, which isn't always the best. All right, ready? So I'm going to put odd. I know you can't see it saying odd, but it says odd. All right. All right, here we go. So this was my original. This made it an even function because I just rotated over that. Take a look at what happened to the odd function. It's upside down. So this image came here. And it rotated around the origin. In order to get here, this did this. Went flip. Okay, and flip. If I blow out a shoulder, someone needs to go get coached. I know, but don't hold that against me.
How do you tell
One-to-one, simplest thing in the world. If it's a picture, if you can draw a horizontal line that touches it twice, not one-to-one. That's the simplest. If you're looking at a list of points or a list of the domain and range, if the range has the same number multiple times, that means it's not one-to-one. Okay? Does that make sense for you? We recorded it. Oh, and you get it. Look what you get back. Oh, hey, wait, stop. Dude, who turned off the projector? Dude.
Come on.
God, man, I tell you, I can't have nice things. Ah. What did I do? Did I cuss? What?
No.
Oh, good. Dude, what's my password?
Try 1, 2, 3, 4.
Okay. All right, came back. Let's go back. Taking that apart. All right. Everyone feel comfortable? All right. So, do you feel, well, you just had my presentation on even and odd. Even though I drew a smiley face, which isn't a function because it didn't pass a vertical line test, it gives you a very good representation of even or odd. Cool?
Yep.
I think it's kind of fun making smiley faces. What is this? Like that's crumpled up. Oh, jeez. All right. Go to page 69. And what kind of questions do we have off the page 69? Oops, I get that. Number 30. Stop. Number 30. All right. It's got the hole through it. It's the very last one.
Oh, the one with 8 through.
Okay, so hat size is a function of head circumference, measured in inches for the circumference between 20 and 7/8 and 25, and these are both in inches. The model related to the hat size circumference is given to by this equation, c minus 1 over 3. What does the little c represent? And this represents inches around the head or the circumference. Okay? What does the SC represent? I don't know where the SC is. I think this is supposed to be this. I think it's supposed to be S at C. And this is the hat size. I just think it was misprinted. And express the domain and range in interval notation. I'm going to hold off on the rest of that one. And then find the hat size for someone with a head circumference of 25 inches. So you go 25 minus 1, that's 24. 24 divided by 3 would be a size 8. Find the head circumference if someone has a size 7. All right, that's 21 equals C minus 1. So the circumference of the last one is that one. I'm not going to worry about the domain and range on those. All right. What? It's easy. All right, you have multiple pages. Stapler's coming around. Once the stapler gets all the way around in your row, just pass it forward. And here comes some notes. You really got 91% of my class?
No, he had a 96. I do this math though. I studied so much. I studied so much.
I love that show.
This might have, I think this might have come from but I don't know. It's number 2. This is why this is from like 49.
Oh.
Usually all
Yeah. Well, I this shows me Oh, yeah.
even function.
All right, does everybody have a sheet? All right, so, ladies and gentlemen, I haven't even started yet.
I know. I mean, 4A. It makes no sense. This is why we don't miss. I did have a picture, but
I bet we'll have something. She said we will every time.
Oh, I thought you had someone else in that. Yeah.
All right, ready?
there's so many.
I'm not gonna match.
I'm not
Like this.
Why you watching
I tried to.
You understand
All right, ready, set, can I go? All right, so we're going to talk about transforming functions. Transforming functions means I want it to move right or left. I want it to move up or down. I want it to flip over the x-axis or the y-axis. And it also could mean I have a stretch or a compression in the vertical way or the horizontal way. We're not going to hit the stretching yet. Okay? So, all I want to do is I want to take something that looks like this, and I want to be able to move it this way or that way, this way or that way. I want to be able to flip the whole thing over the y-axis or flip the whole thing over the x-axis. Good so far? All right, let's play. They give us this table, and there's outputs that come with it. So there's a graph and t-table below is for the parent function. So we're going to call things parent functions or parent graphs. That'll be our original graph. Okay, so far?
Yeah.
So then the next one says, hey, I want you to take our exact graph here. This graph here. Still with me? And now, rather than doing function at x, hang on, we're going to go up 1. So all of my, on this table, this is x, y, agree? So notice, they started it with 0. Why did this become 0? Why did it go from -1 to 0? I added 1. This is going to go to what? So look right here. If I go up 1, it goes to 2. What is this one going to do? Go to 0. What is this one going to do? Go to what? 1. This one right here.
Oh,
And this goes to what?
and that's what we're doing. We're transforming.
All right, so because we added 1.
It's really not that much.
All right,
This is like the
I'm sitting.
I got a D in algebra 1.
Oh, good. What's this for? 4A, bro.
That's why I took it
I
twice.
did get a D in algebra 1.
All right. Oh, that can't be.
That's why I took it twice.
Then how did you load it? Geometry?
No.
Our teacher didn't have options. All
My
right,
teacher
ready?
sucked.
Ready?
Yeah.
Ready?
Yes.
So negative 3 zeros there. Nate, what?
You okay?
4A. Oh.
Sorry.
All right. Hey, sorry about teaching a new concept and some of you want to socialize. If you want to continue your conversation, go to the hall.
I'm not sure.
All right. Ready?
No.
Okay. Does the red that I just drew look like I just moved the original parent function graph up 1?
Yes.
Yes.
Good?
Yes.
All right, what is happening on this one? We'll do it in blue. What's going down 3? The y. So what's going to happen to that point right there? It goes to negative 4. I subtract 3 from this, I get to negative 2. Agreed?
Yeah.
I subtract 3 from this, I get to negative 4.
Yeah.
I subtract 3 from this, I go to negative 3. I subtract and I get to 0. All right, so graph it. Okay, so let's see. Negative 3, 4 is graphed.
You would get negative 1.
What did I do?
0.
It's negative 1, not 0.
Oh, negative 1. I'm sorry. Look, thank you. Keep me honest.
Smart.
All right. Zero, negative 4, 1, 2, 3, 4. 2, negative 3. And 3, negative 1. Does that blue graph appear to have shifted down 3?
Yeah. Yes.
Okay. So if you add or subtract outside of the function, it shifts it up or down.
Down.
No, it does both. Does both. What looks different about this one?
Oh, there's multiple.
Okay, same graph, right?
It's just the X is 2.
So the x minus 2. This is going to shift it right. Anytime something is grouped in math, it's in parentheses, it's in absolute values, it's in brackets, it's going to shift the opposite direction of what you would think. Okay? So this is going to take every x value and switch it. Okay? So honestly, I would look at my graph right here. This point here, this is going to shift right too. So I'm going to go 1, 2. Okay, so I shouldn't do it again.
No, please do it again.
And I should shift right. This one shifts right too.
Can't you just do this by like eyeball?
Okay, am I okay so far? I shift 2.
By like
This
5.
one's going to shift 2. This one's going to shift 2. 1, 2. And then this one. Why am I off? 1, 2. 1, 2. I'm off. I'm off. Where's my graph smaller? 2. No, where am I off? I was trying to keep the attention of some people over on the far side. So being I shifted it to, my x values all change. So this became -1, this became 0, this became +2, this became 4, this became 5. My y value stayed the exact same as this. So that's +1, -1, 0, and 2. So when it's grouped, you affect your x component. It moves it. So if this one shifted it right, what is this one going to do?
Shift it one left.
So it's what? What's it going to do?
Shift it one left.
Okay, 1. Sorry. 1 left. It's not going to do that biological function. It's shifting. It's not excreting information. Sorry about that. All right.
That was a good joke. I'm proud of you.
All right. So the x values don't change at all. Or excuse me, the y values don't change. This is the y value, correct?
Wait, you asked what?
I add 1 to this. So I add 1, I add 1, I add 1, I add 1, and 1.
Okay. Wait.
Okay.
Why
Hang on.
do you-
Hang on. You ready, Olivia? And for those who aren't paying attention, especially the gentleman on the to the left of me. All right. When it's grouped, the x value is shifting in the x direction. Okay? So with me?
Yeah.
There, now you're over there talking.
I'm right along with
No,
you.
don't do that.
Check my notes.
All right. So, being I have something grouped, the y component isn't changed. The y component, remember this, if I write this, this means the same thing as y. Agree? That's f of x.
Okay.
Okay, it means the same thing as y. So this means the same thing as y. So if I have it grouped and nothing else, the y component stays the same. It moves the x component. If it's a negative number, it goes the opposite direction. If it's a positive, it does the opposite of what you would think. All right, let's see if I can write any more without cussing on the board. Sorry about that.
It's okay, we're all cussing today.
All right.
Wait, no.
I think we
So
did some
loud.
shifting figures in this class.
Okay. So if I have that, if it's grouped plus, this is the x shifts left. If I have it grouped like this and I have a minus, the x, come on baby. Okay, does that make sense? These up top are not grouped. They're just adding outside of it. These inside are grouped. It's in parentheses, or it's in absolute values, or it's in square brackets. Can I move on? Sweet. All right. Ready? Take a deep breath. Finish your comment. Ready?
Yep.
If it asks for the negative, that's for the negative. It says the negative of the function. Negative of the function. With me?
Yeah.
So take a look here. Take a look here. Do I have the negative in two different spots?
Yeah.
I did want Sesame Street. Does this, is this the same as this?
No.
Does everyone see how it's different? There's a negative out front, the function notation, and there's a negative inside the function. Okay? Ready? Ready?
Yes.
this, so take a look what this point just did. See where my pointer is? It moved it to here. What did this do? What did it do? Use some terms. My original was right here. It moved up. What did it do? Use terms I can understand.
It made
flipped over the
Flips it over the what?
X-axis. X-axis.
X-axis.
Flipped over X-axis.
Yeah, it should.
Cool? So if I flip over the x-axis, I change all of my signs. So this was a -1. This is now going to be a -1. This is going to be a +1. This is still going to be 0. And this is going to flip to a -2. Got it?
Yep.
All right. So if this flips it over the x-axis, what do you think this flips over?
Y-axis.
Good. So notice this. See how this point started right here? That point had been over here. Look what it had done. It flipped over the y-axis. So that's changing all of my inputs to opposite sign. All of my outputs are the same. Okay? So let me graph this top one so you can see what's happening with it. I don't need this. Okay? Negative. Talk to me about what this picture looks like.
A flip of
You see how it flipped?
Yeah.
Okay? Well, whatever was on the right side is now on the left side. Whatever is on the left side is now on the right side. Make sense?
Yeah.
If I graph this one is red, all right, I have hang on, I forgot a point there. So 3 -1 is here. 2, 1, 0. I had it right, I just forgot to graph everything. All right. We good?
Yeah.
Alright. I don't know what all the giggling is. It has to please stop. Being pretty disrespectful. Alright. Almost done for now. What is this doing? What did it look like it did to this from here? Yeah, so that's going to be then 2. That's going to be then -2. That stays 0. And that becomes 4. Okay? Careful. So that doubled my y values. So this is known as a vertical stretch. All right. What does it appear happened from here to here? Is it a stretch or is it a compression? What did I do to go from -3 to -1.5? Yeah, so this is now a -1. This is still a 0. This is a 1. This is a 1.5. These stay the same. Cool? Yeah. How far did I get? Alright. I want you to, is all homework fast forward? Did the stapler make it around? I want you to try tonight 4B. I want you to try tonight 4B. And I'm not going to mention any names or any specific locations in the class, but a couple of you are starting to be rude. I'm just saying that. I'm saying that in the nicest way I can. Okay?
Mr. Stir,
Talk to me.
so I had work really